into the next component called collaborative cyber physical systems. So generally one good example in this is the robotic surgery. So robotic surgery is a very great example for this collaborative cyber physical system. So it is something like cyber physical system only, but collaborative means, so what are the different collaborations that we can able to think of when we deploying this cyber physical system? Okay. So maybe sorry for the image. So this is I downloaded from a paper. So I have just shared the paper also. See, actually these topics I don't have any textbook available. So I have just taken some literature from the journal papers and then I am just explaining you. So for study material I have just shared the paper also in Moodle. So I already shared the slides as well as the papers in Moodle. Okay. Now in this case here we have embedded systems here. We have large scale CPS here, we have small scale CPS here, and we have a collaborative CPS here. And this is IoT here. So collaborative CPS, it is something like it talks to multiple stakeholders for better efficient collaboration. So there is all the collaborative CPS. So collaborative CPS means all the devices work together, all the systems work together. The humans also will be there. It also works together. So everything works together. That's what we call as a collaborative cyber physical systems. Okay. Now there's a very big definition given here. Maybe in the next slide, I have just make it as a bullet point on all these things. So let me read it out. A collaborative CPS is a system containing interconnected, tightly coupled physical and cyber component. The physical means the hardware as well as the software components with defined borders, allowing identifying the inner and the outer components as well as the inputs and the outputs, jointly acting and sharing information, resources and responsibilities in order to achieve a common goal and operating over a given period of time. So generally the collaborative CPS, they have common goals. They have common goals. So the system parameters needs a common goal to achieve it. So that is what this collaborative CPS is all about. But what are the different characteristics of this collaborative CPS? So bridging physical, social and cyber spaces. So that means physical systems, cyber means software systems and social spaces. That means human connectivity also should be there in the collaborative CPS. So that is the first one. Second thing is organization of communities, devices, humans and systems. So this is what the communities that we use in our system, devices, humans and systems. Okay. So humanized information should also be there. So as I told you that if you take one example called as robotic surgery. So robotic surgery, nowadays robotic surgery is very common. You don't think of the complicated 3 robots are standing there and then doing the operation. Don't think like that. Just think of a small, let's say if you take a sinus problem. So some of you might be having a sinus issue where some kind of extra bone might have been, here. So they will be cutting this bone and then they do some operation. So what do they do is they send a small cable like this, a small, not even this thickness of cable. They send it via your nose. And then there will be a laser light will be there. It goes inside and then it just make it fusing. There will be some fuming in the bone and the bone size will be reduced and then it come out. So this size cable will be a complete robot, a small robot with a small lighting and a camera which will be sent inside and the operation is done. After the operation is done, they can remove the cable out. So there will be doctors there. So doctors will be handling these things. Okay. So it is something called as a robotic surgery. Okay. So that is one. Another thing nowadays is let's say appendicitis. So usually people will say that appendicitis at the stomach. So there is a device called there is a organ called as appendix. So there will be some small infections in the appendix. So if the appendicitis is very bulkier, when it blasts, then there is a chances of death. Okay. So people usually they operate and then take it. So earlier days, what happens? They will do complicated surgery. They'll just cut the stomach and then they open the appendix and then they clear all these things. But now it becomes a laser treatment. That means they dig a small keyhole surgery. They simply called as a keyhole surgery. Keyhole surgery. So that means they put a small opening and inside the small opening they send the robot with a camera and a light, and it will go there. There's a laser light. After that, they apply the laser light according to the potential capability of the patient, and then using the laser light, they just discard the tumors, whatever there in the body, and then it will be removed. And after that, they remove it. So these are all some of the robotic surgery. So please remember, that needs devices, that need humans, and that need systems also to be integrated together. The support of joint efforts. So joint effort support should always be there in these kind of systems. Strong networking among components. This is what very challenging one. Strong networking among the components. So that means each and every device should be strong connection with the networking. See, sometimes what happens, I am just taking in my room. In these systems, the communication should be strong and it should be a real-time communication. That means that the delay, the latency and delay should be very minimal. So in that case, I need to have the strong networking among the component. That means devices, servers, and all these things. Then higher level of smartness and autonomy. So autonomy should be provided and smartness should be more. So it should be very smart and autonomy should be there. So it should not be idiotic. It should be smart. So that's what higher level of smartness and autonomy. See, sometimes when human beings cannot be able to identify something, if the robots is identifying, then we have to give some value or some value-added operations to the robots so that the robot can able to be detected. Because robot uses lenses, cameras to locate something, but human beings based on assumptions we do. Okay, but sometimes human beings can be correct, sometimes robots can be correct. So in that case, there should be autonomy as well as there should be some smartness in the thing. Dynamics and compatibility with the existing system. So existing system dynamics means, see, whenever I brought in new system, so how well it can interact with the existing system. So that is again a greatest challenge nowadays. Okay. So when you purchase a new, let's say a smart speaker, when you purchase a new smart speaker, you brought it to the home. So Alexa, play this song. Okay, Google, do this. Hey Siri, do this. So like kind of devices you just brought in your home. Okay, but when you brought it here, when you see the Wi-Fi, your device is not accepting the Wi-Fi because your router is old, whereas your smart speaker is new. So that means either you change the smart speaker to old smart speaker or change your router to the new router. So it depends. So in that case, what's the dynamics of it? So that is what the dynamics. So because see now, as long as Wi-Fi and this is fine, but just think of a hospital where the robotic surgery is been happening. You purchase a new arm of a robot. You purchase a new arm of a robot that have higher Wi-Fi capability, but your router doesn't have the Wi-Fi capability. So in that case, how you deal with the thing? So you have to change the router, obviously. So that is what the dynamics and the compatibility. Then Agile on the fly configuration. Agile. So Agile methodology is kind of a new. It's a methodology which has been followed by many companies now on the fly. So Agile means every day you have some production. Every day you have some. You have to show some growth every day. Okay. So morning when you go to the company by 9 o'clock and come evening 5 o'clock you are returning home. So by 4:30 they ask you to write a report. So what you achieved today? What was your goals? What was your outcomes? What you achieved today? So you have to write down the points and then submit to the company. Next day morning you go to the 9 o'clock, 9 to 9:30 you have to write what you are going to do today. 4:30 what you have done today. So this is called Agile methodology. So that means the project what you've done 6 months before, now you have to do in 2 months. So that is what Agile. So Agile is something every day you need to show some growth. Okay. So then resilience to various changes in the system or the environment. Resilience. So this is again one of the greatest thing. Whenever any new attacks, vulnerability, everything comes to the existing system, how resilient is your system? Okay, how well it will handle it? Do you have a firewall? Do you have this? See nowadays Wi-Fi passwords can be very easily hacked. These are the very easily hackable solutions available to everyone. See when I am in my home, so when I check my Wi-Fi signal, so you can see here. When I see my Wi-Fi signal here. See, immediately I'm just getting two Wi-Fi signals. So one is mine, another is my neighbors. Okay, so getting into kind of this kind of a Wi-Fi signal is not a very big, great deal. So I can easily able to tamp it down. Now, how well your system is well protected on that. So that is what the challenge or what you might be having in the CPS also. See, whenever you're doing a robotic surgery, someone from the external world they come and attack your robot through some sending some malware, some attacks into the system and make the robot to do perform something different. So how well you can able to handle that? Okay, so that is what the collaborative CPS. And even some time ago, I mean 2 years ago, I just read a paper that the attackers can able to get control of a aircraft. If I mean domestic airplane, a passenger airplane, they can able to get control of an airplane. They can drive by sitting at some remote location. So even they can able to attack the radars also. So That's how the thing are going. So how resilient is your system to counterattack these kind of vulnerabilities? Okay. So these challenges of collaborative CPS is on the privacy, security, management, human orientation, safety, technological evolution, and conflict resolution. So privacy means frequent information exchanges between multiple systems, how it handles it. Addition of devices that has malware in it. So security. So some guest coming to your home, you are giving the Wi-Fi guest role to them. So you are thinking that I'm giving only guest role only now. So only for 1 hour it will run. So in 1 hour the guest is accessing it, but the guest device is already having a malware in the system. So that malware now intrude into your access into your network. Now after the guest is disconnected, but the malware is already in your network. So in that case, there is nothing. The malware can keep on tracking you and sending records to somebody else. So that is what the security will be a very major issue on the collaborative whenever you deal with collaborations. Then device management, how many devices are there, how you add a new set of devices, when a device become obsolete, how you discard that. So these things, the device management. Then human orientation, how you do human in the loop system. So human HATL, human in the loop, how we can able to use human in the loop, because human is also one kind of a collaborator. Then safety, how your system handles fire leakages, water leakages, these kind of safety requirements. Then technological evolution. So that's what I tell about smart speaker. When you purchase a new device that have a latest Wi-Fi technology, but your existing devices doesn't have that. So how you handle that? Then conflicts is always possible in collaboration. So even human confliction and machine confliction. So one machine says that I got this record, another machine says I got this record. So which record is correct? They have to come to a conclusion. So similarly, human. So one good example here is I have air condition. I don't want air condition at this time because it's so cool. But the other person who needs is, let's say, if we take my son, he wanted air condition to be maintained at 29 degrees Celsius, but already it's 26 degree inside. So there's a conflict there. So that means the system has to satisfy both of them and then maintain a common room temperature where both of them will be satisfied. So these kind of things are some of the challenges of collaborative CPS.